This is the final program of our analytical chemistry series, and I'm going to call it Putting It All Together, where I'm going to try to integrate all three spectra to determine the structure of an organic compound. I'm going to begin with a halogenoalkane, where we're given the percent composition of the compound and all three of its spectra. The first spectra I'm going to take a look at is its mass spectrum. Of particular interest is the far right end, which represents the parent molecule, where the entire molecule gets through and doesn't break apart. So zooming in that region about 110 and beyond, I can actually see there's three smaller peaks there at 112, 114, and 116. From those I can determine the molar mass. Let's return now to the percent composition data. I'm going to take each of the elements and divide it into a column, convert the percentage of mass by assuming 100 grams, and then convert those masses into moles by dividing by the molar mass of each element. At this point, I don't see a very clear ratio, so I'm going to divide by the lowest one, and that'll give me the following information. 1.5 to 2.9 to 1, if I double each of those terms, gives me 3 to 6 to 2. So I can assume now that the empirical formula is C3H6Cl2. And that empirical formula has a molar mass of 113. One thing I should note is that we actually don't have a molecule that weighs 113. Chlorine comes in two isotopes, one that weighs 35 and the other that weighs 37. The weight that you get from your periodic table is a weighted average of those numbers. So the peak at 112 corresponds to the compound where both of the chlorines are 35, and the 116 corresponds to the peak where both of the chlorines weigh 37. 114 happens when you have one of each. Since the molar mass matches closely the mass in the parent peak, I can assume that the molar mass and the empirical formula in this case are essentially the same. So beginning with that molecular formula, I'm going to come up and draw the isotopes that are possible based on that formula. 1,1-dichloropropane, 1,2-dichloropropane, 1,3-dichloropropane, and 2,2-dichloropropane. Let's take a look at the infrared spectra. From here I notice a large valley at 3,000 and again somewhere around 700 or 800 a couple of large valleys. Those correspond to CH and CCl bonds. Not too surprising because this is a halogenoalkane. If I had information in the 1500 to 500 region, if I had a library of data, I could use that fingerprint region and match my chemical there as well. But I don't have that. So we'll go on and take a little bit more close look at the fragment analysis. So back to the mass spectrum. There's a large peak at 63. That corresponds to the following molecular ion. I can get that molecular ion by removing CH2Cl from my molecule. If I look at the first of my molecules, the 1,1-dichloropropane, I can't easily remove that fragment from that molecule. But in the next one, I just need to cut it off here at the end. Likewise, in the next molecule, I can cut either the right end off or the left end off and obtain that fragment. And I can't get that fragment from my final molecule. So I'm inclined to believe at this point that these two isomers are the possible structures of my compound. To go further, let's look at the NMR. So again, my two candidates. Before I present the NMR, let's make some predictions. An examination of the molecule at the top, the 1,2-dichloropropane, I can see 3 hydrogen environments, and I would expect a ratio of 2 to 1 to 3. If I look at the molecule below, there are really only 2 hydrogen environments, and I would expect a ratio of 2 to 4 or 1 to 2. Let's take a look at the actual spectrum. Here I can see the 1 to 2 to 3 ratio that's present, confirming it's the top molecule. So I can confirm from this that 1,2-dichloropropane fits all of the evidence that I have. So take note that no one piece of evidence by itself can determine usually the formula of a chemical. It's the integration of all 3 pieces of information that leads to identifying the structure. Questions are always welcome, and don't hesitate to make a comment. Thanks for watching.